Okay, these are going to be the next two tests. And let me just show you really quickly. If I can get the pen. Can I get the pen? I do very badly with the pen. Zoom is being pretty obnoxious to me. Okay, so p-test. Love the p-test. P-test is great. P-test only applies if there's a 1 on the top. And then the big one is the integral test. This is what you're going to do. This is why we spent time doing improper integrals. So you're going to be taking integrals from 1 to infinity or whatever. Like, in this little cheat sheet, he used c for the starting point. It could start at 1, it could start at 2, it could start at 0, it could start anywhere. This is complicated now, right? F must be continuous, positive, decreasing, and readily integrable, meaning integrated. So all that ridiculous nonsense just meant you're going to do the integral from 1 to infinity of each of these. Now, I'm going to rewrite this up here. That's really 6n to the 1/3 power, right? This is my sequence, right? This is my list of numbers. The series is the sum. The sequence is the list of numbers. So I'm going to integrate this. Now, I don't want it like that. I want to put it in the correct form. If I'm going to do my integral, my antiderivative, I have to write it like this. Now, I'm going to add 1 to the power. So you're going to get n to the 2/3. Now, remember what I taught you to do. Flip that over, put it in the front. But there's already a 6 there. Divide the 6 by 2 first to get a 3. 3 times 3 is 9. So we do that quick. So this is what you should get. Now, I have to evaluate my antiderivative from 1 to infinity. Right? This is what you do. First you integrate, then you plug in. Now, when we were doing these, we wrote lim, this and that. No more, right? This is too much. And technically, I'm supposed to put a dn here. Right? This is an antiderivative. I'm supposed to write dn for derivative, but not doing that either. You want to do these fast, right? These are supposed to be quickies. So, you got to do a little bit of precise. You have to integrate it right. So now when you put infinity in there, you're going to do infinity to the 2/3, and then you're going to do 1 to the 2/3. But this is kind of ridiculous. No matter what power you raise infinity to, you're going to get infinity. And if you multiply infinity by 9, it's still infinity. So 1 to any power is 1, so you get infinity minus 9. If you had forever and you lost 9 days, you still have forever. So this integral diverged. So if the integral doesn't work, that means that the sum doesn't work. So then you would write diverge by the integral test. I don't want to write all this out. So the original sum is going to diverge. So this is the way the game is going to work. I'm always going to do the integral from 1 to infinity. As long as I can integrate this, I'm going to rewrite it in the way that I want so I can use the reverse power rule. Yes, I'm supposed to have dn here because I'm doing an integral. So I'm going to add 1 to the power, which makes it n to the minus 3. Flip that over, put it in the front. And then I want to evaluate this from 1 to infinity. Now, you're going to do a computation. Do not leave a negative exponent there, right? Move it down. You know better. You don't want to leave it, though. You got to plug things in. And I understand you're plugging in infinity, but you're also plugging in 1. So first you put infinity there, right? And again, infinity to the 3rd is going to be infinity. 3 times infinity is infinity. So now be careful with your signs. You're going to plug 1 in. 1 to the 3rd is 1. So let's just cut to the chase there. Now, over here, you get negative 2 over infinity. But that's equal to 0. You're dividing a constant by forever. And over here, you just get positive 2/3. That is finite. That integral exists, right? We started to use that language when we did improper integrals, converging, diverging. That integral converged because it was finite, and it came out to a nice number that's not BS, like something 0 on the bottom or whatever. So if the integral exists and converges, that meant that the sum converged by the integral test. Okay, so this is always the same game. Integrate from 1 to infinity, or, depending on what I gave you, like, I'm going to give you a silly example. I mean, I could give you something like 1 over n minus 4. I would not start this sum at 4 because it would create a 0 here. So what I would do, if it was like n minus 4 on the bottom, I'd start that sum at 5 so that it's going to start to be good, right? You can't put a number here where it's going to fail. So that's an example of where it might not start at 1, but I try to avoid crap like that. So I'm going to do a bunch more. Okay, the next 2, same game. I'm going to take what I start with. I'm going to integrate from 1 to infinity. you have to have something you can integrate. And this is why when you start to learn more tests, it gets complicated because you have to recognize when to use what test. So that's why I'm going to do a lot of these. Now, I want to point out, we integrated stuff like this. We integrated stuff like this, right? We did a lot of these integrals. This one is just ln. This is ln of n. Now, if I had put a 2 here, then I would put a 2 here. But this one has a 3 here. So this integral is going to be ln, 3n plus 1. But remember, how ln goes, right? It's du over u. There should be a 3 here, but there's a 1. That meant that I had a 1/3 there. And yes, you have to integrate these correctly. So this is the antiderivative. I'm going to now evaluate that from 1 to infinity. So you're going to put infinity in there. So look, 3 times infinity plus 1 is infinity. So cut to the chase. Over here, you're going to get ln. 3 times 1 plus 1 is 4. This is fine. I have no idea what the hell ln 4 is, but I know it's a finite number. This is not, however, right? Ln, you should never, ever remember this graph, but ln looks kind of like that. It grows larger and larger and larger as you approach infinity. So ln is not infinite. So this right there kills the whole integral. Doesn't matter that this works. This makes the integral fail. Hence, this diverges by the integral test. And you should write diverge by integral test. I mean, I should be writing that, but I'm trying to do them fast. So integral from 1 to infinity. Now, again, you know the integral, like, if I'm going to use n. You know that that one would be e to the n. You know that if I had a 2 there, you put a 1/2. You know that if this was a 3, you'd put a 1/3, right? So I have a -1 there. So first I got to write this down. Integral 2e minus n. So when I find that antiderivative, it's going to be -2e to the negative n, evaluated at 1 to infinity, right? First you write the indefinite integral. Then you integrate it, and you plug in. Now you got to be careful here. Like the problem I did before, you're going to rewrite it. So let me just do it. No, I'll do it over here. I want to leave that there. You're gonna flip this one down, right? You have e to the negative n. You do not compute with negative exponents. Make it positive. Make it easy for yourself. All right? So move the e minus n down as plus n. Now put infinity in there. You get e to the infinity minus -2 over e to the 1, which is just e. Now, e to the infinity. E is exponential. It's like 2.7. You do an infinite powers of that. Of course, that's infinity. Some people didn't know what to do with this. Over here, you get +2 e to the 1. Now, this, you're dividing a constant by infinity, just like the example I did before. It's 0. And you have something finite that exists. Now, I have no idea what the hell 2 divided by 2.7 is. It's less than 1. So I know that integral converged. The integral converged. The integral exists. It's finite. This integral worked. Hence, the original series has to converge by the integral test. All right, so I did the improper integral from 1 to infinity. I found that it converged. Now, important again, I want to point this out. I said in class, but this is not the sum. This is not geometric. The integral, now I'll tell you, the sum is actually close to this, but this is never the sum. You cannot find the sum this way. The integral test will only tell you converge, diverge. You're not going to find the sum anymore unless something is geometric. All right, so I'm going to do a few more. Okay, these are 5 and 6 on the sheet now. They are there for one specific reason, to show you how to recognize that the tests you did before are always in play. This is not an integral test. This is not an integral test. Good luck trying to integrate those. You're welcome to try. You cannot integrate these. All right, then you'd have to do this by long division, for crying out loud. Right, the top and the bottom. This is not ln, but this is really easy. If I take the limit as n goes to infinity, Jesus, nice infinity. If I take the limit as n goes to infinity of that, right, L'Hopital, highest power, you get 1/2. That's not equal to 0, hence diverge by the limit test. So simple, but you have to recognize that, the series are going to be mixed together. I do try to group them. Look, my colleagues do not do this. I can tell you that if you have another professor other than me, your series is going to be all over the place. I do try to group them by test category, but You cannot count on that. You might have like 10 of them on a page, and you have to recognize this one's this one's this. They're all different tests. So you have to always, I had said very specifically, this is always the first thing you look for. Now, this is geometric. How do you know it's powers of 2 and powers of 3? The ratio is 2/3. If you don't believe me, write out. I did this in another video. I'm not doing it again. The ratio is 2/3, which is less than 1. Hence, converge by the geometric series test. I will tell you the sum is 12. If you want to go check it out yourself, feel free. I'm not doing it again. But just to show you that even though this sheet is for the integral test and the p-test, I mixed in a bunch of other ones. So I'm going to do those now. Okay, the next two, by far, my favorite test of all of them. I'm going to rewrite these real quick. I have a negative exponent. You never want to leave it as a negative exponent. So I'm going to move it down. Now, this other one, you do not want to leave it as a radical. Okay, so now, that's n to the 4th. Look, n to the 4th. But I have the 5th root, so the 5 goes there. If you screw that up and write 5/4, I don't know what the hell you're doing in Calc 2, number 1, but number 2, you get the whole fucking problem wrong. You cannot get this power, you cannot rewrite this power wrong. So remember, the root always goes on the bottom. That's N4, right? Look, N4, you have to just, whatever that is, it goes on top. Now the p-test. Love the p-test. P-test is the best. Why can I use it? Because there's a 1 on top. If this was a 4, you'd have to use the integral test. But it's not, it's a 1. Yay! So p-test, the power is 3/2, which is bigger than 1. Hence, converge. Yay! P-test is the best. Here, p, the power, is 4/5. Why can I use the p-test? Because there's a 1 there. That power is less than or equal to 1. Hence, diverge by the p-test. I'll even write it this time because I love the p-test. P-test is the best. As long as you have a 1 on top, I gave you a gift. If it's anything else, any other number, if that's an 8, integral test. If it's a 3, integral test. But if it's a 1, p-test, because the p-test has to look like this. 1 over n to the p. If this is 1, diverge. If it's less than 1, diverge. If it's bigger than 1, converge. Very simple. Love the p-test. P-test quick. I'll give you p-test just to have fast ones to do. Okay, so I'm going to skip around a little bit, and I need to get to the one that literally most of my class couldn't do, which was a little ridiculous, but I'm going to do it anyway. Now, as soon as you see that one, you're like, I don't know what to do. It's an integral test. This is not an integral test. You cannot integrate this, okay? The thing on the top is n to the 1/2. The thing on the bottom is n cubed. This, if the top was 3n, if the bottom was like this, and the top was 3n squared, that would be natural log. But it's not. The top is not the derivative of the bottom. What you have to do is use the exponent rule. So very simple, right? When you have like x to the 5 over x to the 2, you just subtract the powers, right? Division means subtraction, so you'd have x to the 3rd there. So you have to subtract these. You have to start with 1/2, subtract 3, right? Top power minus the bottom power. So 3 is 6/2. That gives you a power of -5/2. Now, as I said, over and over and over. Don't leave negatives in the power. Flip it down and make the power positive. Oh my God, look what I got. I got a 1 on the top. Yay, it's p-test. Power is 5/2, which is bigger than 1. If you cannot tell 5 divided by 2 is bigger than 1 without a calculator, I don't know what the hell to tell you. So this is going to converge by the p-test. So when you see something like that, again, trying to recognize what to use. Got to simplify it first. You have to simplify it. And then you see that it boils down to a p-test, which doesn't get any easier. Can you still use the integral test? Absolutely. But why would you when you can use the p-test? It's faster. Now, this is the one that the class universally had trouble with when I gave it to you as an improper integral. First things first, you got to write it that way. Right? Radical means 1/2 power. So now I'm going to integrate from 1 to infinity. I'm not going to leave that like that. I'm going to move it up to the -1/2. Now look, technically this is a u substitution. The u is n minus 5. The du is, the derivative of n is 1. You don't even have to do a u substitution here. You can just integrate the damn thing. You just add 1 to the power and divide by the new power. You know, if that was 2n minus 5, you'd have to put a 1/2 out there. But I deliberately gave you easy BS. So all you have to do is add 1 to that power, which gives you n minus 5 to the positive 1/2, right? And then flip that over, put it in the front. So that's a 2. You hook it up with that 3. That's going to make the 6. Look, you have to integrate them right. When I'm grading this, if I see, and you're going to evaluate it from 1 to infinity, if I see that the integral is incorrect, I will mark this wrong. If you still get the right conclusion, converge, diverge, I'll give it to you. But you're going to lose a point for integrating this right. You have to have that correct, right? So you rewrite it with an exponent. You move it up so that you can actually take the antiderivative of it, add 1 to the power, flip that power over, put it in the front. That's a 2, though. And you hit it with the 3. So now when you integrate this, now it does help to do this. Put it back the way it's supposed to be. I probably should have underlined that. Now it looks like a fraction. So there. You're going to evaluate this from 1 to infinity. So you're going to take the square root of infinity. Infinity minus 5, infinity. Square root of infinity, infinity. 6 times infinity, infinity. Minus, now over here you just get square root of, oh man. Wow. This had to start at 6. Oh, problem on the sheet that's fucked up and I didn't realize it when I made it. This has to be a 6. I really should have realized this before this, but I didn't. So I'm going to have to go back and fix. You see the problem? If I put 1, boy, this is double bullshit. You get 1 minus 5, which is radical negative 4. Not only do you get infinity, but you get I. Well, this is double whammy. All right, so this integral was all kinds of fucked up. So this didn't work. This had to be a 6. That's the reason. Yeah, you have to have a 6 here. So when you plug 6 in, you get radical 6 minus 5, which is radical 1, which you can actually do, but who gives a damn? You still got infinity. This thing is still going to diverge very badly. So this is the exact example that I was talking about before I screwed this up. This cannot have been a 1. It's not defined, right? I mean, if this is 1, you get radical negative 4. So it had to start at 6. Like I was telling you in a previous example that if I had a different bottom, and then I'm doing this myself, and I didn't even catch it till the end, but I did catch it. So now I got to fix that. But so either way, infinity, diverge. So okay, I made a bad problem. I fixed it though. It still didn't work. Even if the problem had started with a 6, it still diverges, so it doesn't matter. All right, so maybe I'll do 1 more or 2 more. All right, we'll do these 2 and then we'll call it quits. So I put 13 and 14 up there. I'm going to do 14 first just to show, because I can do this one faster. When you put infinity in there, you get e to the infinity over 6 to infinity, which is infinity over infinity, which is indeterminate, okay? So remember, the first thing you're checking for, make sure that the limit is 0. You're kind of doing this in your head, right? You don't write this out. But this one is not clear. Is it 0? Is it not 0? So since it's indeterminate, you're going to use L'Hopital rule. So I'm going to use the L'Hopital rule on this one. I'm going to take the derivative of the top and the derivative of the bottom, but look what happened. Derivative of e to the n is e to the n, but the derivative of 6n is 6. So now when I do this limit again as n goes to infinity, it's not going to be indeterminate this time. I have e to the infinity, which is infinity. And I don't care how much you try to divide infinity up. I'm going to split forever up into 6 chunks. It's still infinity. All right, infinite amount of money over 6 people, everybody gets infinity. So that one's going to diverge. The limit's not 0. The limit is not 0, hence it failed the limit test. So this is a diverge by the limit test. The very first one I showed you. Now this one will be integral test. So remember, when you're integrating stuff with e, right? I mean, if I just gave you this integral, you'd be totally screwed. Because remember, it's supposed to be du times e to the u. You need the derivative here. I have to put like a 2x here so that that derivative goes there. And that derivative of that actually is minus 2x. So you're missing a negative here. So you always want that derivative there. So you have n squared, you need an n there. If I don't put that n there, you cannot integrate this easily. You would have to try to integrate this by parts, and why the hell would I? The whole purpose of the integral test is they're fast, easy integrals to compute. Cannot give you nasty integrals. you're never going to see trig substitution. I can't even, think of one off the top of my head that's, here. Something like that. That's trig substitution. Yeah, that integral takes like 15 minutes just to do. I mean, it's ridiculous. You can't. These are meant to be very fast. Now, this one is a little more complicated. You have u. You have du. So what I wanted there was a negative 2n, but I have a 4. So I have to double that and times it by a negative. So I'm going to do the integral from 1 to infinity of 4n e to the negative n squared. That antiderivative, all right? So now be careful. You're going to have e to the negative n squared. All I need in the front is a negative 2, right? If I times negative 2n by negative 2, I get positive 4n, right? Negative 2 times negative 2 is positive 4, and then the n goes along for the ride. And then I'm going to evaluate that from 1 to infinity, right? So it's a basic u substitution. You don't need to do the substitution. You should be at the point now in this class that you can do these basic u substitution ones in your head a little bit. Now, remember what I just said. Never, ever, ever evaluate it with a negative power. You don't want to do that. So you're going to move it down. Now you plug in infinity, but hopefully you see what's going to happen. You're going to have e to the infinity squared. Hello. That's e to the infinity. You're going to have 1. 1 squared is 1. So this works out almost exactly like the other one. You get negative 2 over infinity, which becomes 0. Over here, you get a positive 2 over e. So again, this is a finite result. This improper integral exists, converged. Hence, this converged by the integral test. I don't want to write the word integral out, so converge. So if the integral exists, the improper integral, then converge. If the improper integral were to fail, and you could get some crazy stuff. I mean, you might end up with a 0 on the bottom. You might end up, you just end up with weird things. Anything that doesn't work, then the integral failed. That means diverge. Okay, so I try to do as many of these as I can. Integral test is not complicated. They will be basic integrals, but you do have to recognize, again, it's important. If you see something like this versus something like this, I mean, I really wish you could use the p-test, and I'm going to tell you a big secret, how I can do them so fast. The p-test does work on everything, but you're not allowed to use it unless there's a 1. I mean, you might think that the 6 definitely affects the sum. That's why you have to use the integral test on this one to show that this would still converge. But, if that power is more than 1, it's going to work. If I had switched that power to 1/2, then it's going to diverge. Doesn't matter what's on top. It's only when I start mixing them up. But, the tests are going to get more complicated. The integral test is not that bad. The p-test is the best. Love the p-test. All right, so hopefully. I mean, I did as many as I possibly could, so